Hello, ladies and gentlemen. Today's topic is combining like terms and one and two-step equations. This should be a review topic for you guys. I'm really hoping it is and that this lesson isn't too difficult for you because these two skills, combining like terms and solving equations, are really the basis for a lot of what we're going to be doing for the rest of this year. Please remember to put your date and your page number. As I was doing notebook checks this weekend, I saw that a lot of people weren't really doing that, and it really hurt some of your grades. Okay, so please, please, please try and remember to put those things on every single page of your notebook. So if you would please write the objective. I can combine like terms, including questions with distributive property, and solve one and two-step equations. So there's a lot we're going to be doing today, but we're going to move through it pretty quickly because it should be review. If we're going through this and it seems like you've never seen this before, you might want to find some additional resources to help you or plan on staying after school, perhaps Monday or Friday, to get some extra help on this. So there are some terms that we need to be familiar with, some vocabulary words. So I know that this is a little bit of writing here, but go ahead and pause the video and write all of these definitions down. And as you're writing them down, make sure you really try and figure out what they mean and try and commit them to memory. A lot of it should be review for you. So pause the video, write down these vocabulary words, and then we'll continue. All right, hopefully you paused the video and got those written down. On the next page, page 31 of your notebook, let's go ahead and work through an example of combining like terms. And we're going to do a fairly complex one right off the bat because I think you guys are probably ready for it. So we have 3m plus 2n minus 9 minus 5, parentheses, 2m minus 3, close parentheses, minus 5n. That is a lot going on. The first thing we're going to do is go through and change all of our subtraction here to adding the opposite. It's just going to make it easier when we go to solve this. So we have 3m plus 2n. Instead of minus 9, we're going to do plus negative 9. Instead of minus 5, we're going to do plus negative 5. And then we have our parentheses 2m plus negative 3. And then finally plus negative 5n. Okay, and I left my fancy little pen at school, guys, so hopefully the writing is legible enough for you to understand. All right, now we have to figure out what to do with these parentheses because we have to get rid of those before we can really start combining any like terms. We are going to use distributive property, take this first term and multiply it by each term on the inside. Very important that you remember to multiply it by both terms. So I'm going to have negative 5 times 2m. Negative 5 times 2 is negative 10. And then I'm going to keep my variable m. And then I'm going to have plus negative 5 times negative 3. A negative times a negative is a positive, so that should be plus 15. I'm going to bring down the rest of my expression. Sorry if my 5s look a little bit like S's. Bring it all down. And now we can finally work on combining our like terms. That was a big M. Okay, so when we combine like terms, I like to use different colors to identify the different terms. So I am going to use white for all of my M terms. So I'm going to put a little circle around that. My other M terms are this, oh, that should be plus negative 10m. Sorry, guys, I forgot to bring that addition down. This negative 10m is another M term. So when I combine like terms, I look for two terms that have the exact same variable part, and then I simply add the exponent, not the exponents, the variable. So if I have 3m plus negative 10m, I'm going to use my rules of integers to know that 3 plus negative 10 is negative 7, and then keep the m, the variable. Now, how about I use a lovely purple color for my n terms? So here's one n term, 2n. And I'm going to find another term that has the exact same variable, That's negative 5n. So I'm going to do the same process there. 2n plus negative 5n. Add my coefficients, 2 plus negative 5, and that gives me negative 3n. And last but not least, we can't forget our constant terms. How about light blue? Our constant terms are terms that do not have a variable. So I have negative 9 and positive 15. Negative 9 plus 15. That is going to end up giving me 6. So my final answer here is going to be the sum of all of these different parts that I just found out right here. So it's going to be negative 7m plus negative 3n plus 6. All right, make sure you have all of that work copied down in your notebook on page 31, nice and neatly, neater than mine because I don't have my pen today. And let's go ahead and talk about the other half of the lesson today, which is solving equations. You should be able to fit this on the same page. This shouldn't have taken you too much room. So we're still on page 31. And go ahead and write like another heading halfway down the page that says solving equations. We're going to talk about one-step and two-step equations today. We're throwing it all at you at once. So my one-step equation is negative 3m equals 12. Anytime you're solving equations, I want you to use inverse operations. And I know that you guys have probably, ooh, that was a weird E. I know that you guys have probably heard this term before last year, or at least I hope you have. Inverse operations tell us how to undo an operation that's happening to a variable. An operation could be addition, subtraction, multiplication, division. It could even be square or square root. So in order to solve this, there's a certain way that I want you to show your work. First of all, I want you to draw a little balance, okay? And then you have to figure out what is happening to my variable. What is happening to m? I have a negative 3 right next to it. And anytime I have a number next to a variable, that's multiplication. So how do I undo that multiplication? Well, I'm just going to divide by that same number. Divide by negative 3. Get in the habit of using this fraction bar symbol for division. It's going to make things a lot easier for you down the road. Instead of using this division sign, do a fraction bar. Okay, because we all know that fractions, a fraction bar really means the same as division. So when I divide both sides by negative 3, on the left-hand side, my multiplied by negative 3 and my divided by negative 3 cancel, and I'm left with m. And then I can bring my equal sign down, and I have 12 divided by negative 3. A positive divided by a negative is a negative, and 12 divided by 3 is 4. Okay? Now let's look at a two-step equation, which is a little bit more complicated. When you're doing a two-step equation, the hard part is figuring out what to undo first. Do I undo 4 multiplied by p first, or do I undo minus 4 first? And the best way I can think of to remember that is to think about PEMDAS spelled backwards. And PEMDAS backwards is the same, it is what I like to call SADMEP. And that tells you what order to solve equations with, what order to undo your operations with. So first I have subtraction and addition when I'm talking about SADMEP. And that means I'm going to undo this subtraction first. So I'll draw a little balance, and I'm going to undo subtracting 4 by adding 4. Add that to both sides, and I'm left with 4p equals 20, because 16 plus 4 is 20. So that was my first step of my two-step equation. Let me make this screen a little bigger so I don't run out of room. Then, and that's a 4, guys, if you can't tell. Then I'm going to ask myself, okay, well, I still have something attached to my p, and I need to get rid of that. So I need to take the next step in SADMEP, which is undoing division and multiplication. So when I undo this multiplication, because that's the hidden operation between 4 and p, I'm going to divide both sides by p. Oh, should have drawn my little balance. Sorry, guys. The balance helps remind me that whatever I do to one side, I have to do to the other side. So I've divided both sides by by 4. On the left-hand side, I end up with P, and on the right-hand side, I get 20 divided by 4, which gives me 5. All right, make sure you've written all those notes down, including this inverse operations note and SADMEP. And then for your reflection, I want you to simplify this expression here and then type it into Edmodo. All right, thank you guys. Have a good night, and I look forward to reading your response.